Hello everyone, today we're going to be working on how to construct the truth table of our two basic statements or compound statements. So in negation, if we're going to transform our negation value into a truth table, let's say we have a value of p. The value of p could be a truth statement or a false statement, and if we're going to negate our statement p, that means we're just going to use the opposite truth of that particular statement. So if P is true, not P is false. If P is false, not P is true. So you're just going to negate your function, and this is how we apply the operation of negation in a truth table, which we're going to be using in a little while. Now let's say we're going to be working on a compound statements, which means we have two statements or two basic statements, and we're going to combine them using an operation. We have several operations that we could use, and for today we're going to be seeing the conjunction and the disjunction operation and how we can create a truth table out of those two operations. So in this particular table, you're seeing P and Q, which is a conjunction operation. And in a conjunction operation, according to the definition, the only time that the two statements will be true is when both statements are true, which means on the first row we have T and T. That means P and Q will be a truth statement, and if we have T and F is going to be false. F and T is also going to be false, and false is also going to be false in this particular truth table on conjunction. So this particular rule only applies for an AND operation. Now what if we have a disjunction or an OR operation? How is our statements going to change when we incorporate a different operation? According to the definition, the disjunction is only false when both statements are false. Else, the rest of them will be true. So if we have P and Q and we're going to find the value of P or Q, that means according to the statement, it will only be false when both of them are false. That means T and T will be true, T and F will be true, F and T will also be true, and the only combination that will give us a false statement is when P and Q are both false. So these are some of the facts or some of the value that you need to remember when you're constructing your own truth table using disjunction and conjunction. So let's say we have two statements, actual statements, P and Q, wherein P is 10 is greater than 4, which is a truth statement, and Q, which is 3 less than 5, which is also a true statement. That means if we're going to determine the value of the compound statements that we have on problem 1 and number 2, starting with P and Q, we know that P is a truth statement, and we know that Q is also a truth statement. And if we're going to look at our truth table on conjunction, two T's will make up a T. So number 1 is a truth statement given that we're using the conjunction table of our truth table. Now for number 2, if we have not P, that means it's false, and if we have Q, that means it's a true value. And in our conjunction table, if we have F and T, the statement would be false. So statement number 2 would be false. Now let's say we have two more statements given by P and Q being the same value as the previous example. If we're going to determine the truth statement for problem number 3, which is P or not Q, that means we're going to be using the disjunction table. So using the disjunction table, we'll be able to verify if number 3 and number 4 are both, or number 3 and number 4 will be true or false. So for number 3, P is going to be true, not Q is going to be false, so T or F is going to be true. Because in the definition of a disjunction, the only time that it's going to be false is when both statements will be false. So for number 4, not P is an F, not Q is also an F. That means this statement is going to be a false statement. So this is how we use the disjunction and the conjunction table to be able to verify a compound statement. Now let's say our compound statement includes two different operations, which in this case is going to be the quantity of P and Q and then the negation of that parentheses. So if we're going to be using the conjunction table, because this is a conjunction operation, we know that P and Q will have the following values given that we have the P and the Q statements. So if we're going to come up with another column that would indicate the symbolic form of our truth table for not quantity P and Q, all we have to do is to basically ignore the first two columns so that we can concentrate on P and Q. And what we're going to do with that is we're going to negate it. And if we negate it, it means we're going to find the opposite value of our truth table. So for the last column, not P and Q would simply be false, true, true, and true. So now we have the complete form of our truth table for this specific operation. Now, if we're going to make sense of this particular statement, let's say that we have an actual statement for P and Q. So P is that Harvard is a college and Q is Yale is a college. If we're going to translate our symbolic form into an English form using the given statement, P and Q is simply Harvard is a college and Yale is a college, which is a truth statement. And if we're going to be using our fourth column, which is not quantity P and Q, that means we're going to negate both P and Q in the process, and our English statement would be Harvard is not a college and Yale is not a college, which is in this case is a false statement because of our truth table. So this is how we're going to work on compound statements using the truth table. Now there's a special case for two compound statements with both meaning being truth and then when it's not both true or truth statement. We call it a tautology. So this compound statements that we have in our example is not a tautology because P and Q is true and its opposite operation, which is not P and Q, is false. And when that happens, we call it a tautology because by definition, a compound statement that is always true is called a tautology, and in this case it's not always true because not P and Q is a false statement. So another example of an operation that we could work on and create a truth table out of it would be this particular example. So here we have a parenthesis not P and Q or not P or Q parentheses and not Q. So in this case, we'll be able to see that we have two groups of statements in this operation. We have the ones inside the parentheses and the negation of Q. So if we're going to create a truth table based on this operation, what we need to do is we need to start with our basic statement, which is we will assume that P and Q will have the following combination of outcomes. So we can have a statement that's both true, a statement that the first statement is true and the other statement is false, a statement that is F and T, and then when both of them are false. So these are the possible combination of truth value that we can have for two statements such as P and statement Q. Now, if we're going to negate P, because on the first operation under the green group, not P is what we need to be able to construct not P and Q. So if we're going to negate P, that means the value of our not P would be FFTT, which is the negated value of column P. And if we're going to simplify not P or Q, we're going to be using the disjunction table. And according to this table, the only time that it will be false is when you have two statements that are false. So if we're going to look at our column for Q and not P, the only time that it will be false will be at the second row. So that means the first row, TF, is going to be true, FF is false, true or true is going to be true, and then false or true is going to be true. So now that we have our table for not P or Q, what we're going to do is we're going to look at our second group, which is not Q, and negate our Q column. So that means our Q column will have the opposite value of TF, TF, so not Q would be FT, FT. But since we are looking for the combination of the two compound statements, which is the quantity of not P and Q, the quantity of not P or Q and not Q, we're going to ignore the first three columns and just concentrate on our latest two columns, because here we can now use the conjunction operation, and in the conjunction operation we'll notice that the only time that it will be a truth statement is when the two statements are both true. So that means for the first row, T and F, it would be false, F and T would be false, T and F would be false, and then the last statement, T and T, that's the only statement that it would be true. So this is now our truth table for the operation of not P or Q and not Q.